The optical sensor that pulls in images and the microphones that pull in audio, um, they pipe that as fast as possible over Bluetooth down to your phone. And your phone acts as a relay point. Now, we're in the midst of, uh, without sort of telegraphing some of our future plans, but you can probably surmise where we're going with this. It's all over the place. But our developer community is also similarly global. I mean, we've got over 13,000 folks at this point who've been playing with the SDK and building things, and many of them are, of course, like intrepid indie hackers building cool stuff. Many of them are folks in corporate. They're building an interesting proof of concept to pitch to folks internally and build out a broader program from there. So it really runs a wide spectrum. And then like half of Silicon Valley are our customers. People who are doing interesting AI models or agentic systems, and they want a way to deploy that in front of the human eye. And we've seen this generally. There is this, not just a consciousness, it feels like it's now becoming like an anxious yearning for a lot of folks building in technology to have that, especially AI, to have that experience by other human beings. And the most immediate way to do that, if it's not like an app on a phone or something, is for it to be in front of someone's eyes and responsive to what they see and hear. Like that's when you get the most rich, multimodal, interactive form of computing. And so we're seeing a lot of people come and buy our stuff and play with the SDK, wanting to get their cool system in front of someone's eyes so that people are like feeling what they built, not just intellectualizing it.
Thousands of developers, indie hackers, corporate teams, half of Silicon Valley. That's not typical for an open source hardware platform, especially one launched by a team of fewer than 10 people. But here's what's driving that adoption. So AI teams, they're building agents and they're building models and they're building systems, and they're hitting a wall because the demos, well, they're running in a terminal, or it's an API endpoint, or it's a chat interface. Nobody feels it. Nobody is experiencing it in context. Brilliant Labs offers something different. Your AI model, well, it can see what you see, it can hear what you hear, and it can respond in near real time.
Yeah, for us, there's different sort of inputs to the whole thing. There's the audio side, the video side, there's timestamps and locations, IMU data. And so, the where, the why, the when. We try to surmise about things like how and who. And so we paint this whole picture. And that's part of some of what we've built up on the AI side of things. And then how we index that data. It's not only for, the usual kind of quick, vector recall, the semantic similarity stuff that at this point is now pretty well trodden territory. But it's also trying to understand how this data is connected over time. If you zoom out, all of this stuff, like an agent is basically getting a first person point of view on your life. And just like we have a map of meaning in our own minds, we've got a world model that sits in our mind that assigns meaning to the people and the things and the places that we do and go and see. An agent needs that too. It doesn't naturally have that. And we've needed to think deeply about what that ought to look like.
This is where spatial gets pretty interesting and tricky. Audio, video, timestamps, location, IMU data. That's 5 data types all coming in real time. So you could do vector search, semantic similarities, and that's a standard approach now, index the embeddings, retrieve relevant context. But Bobak's describing something more sophisticated and ambitious. A graph ontology that tracks how data connects over time. A world model assigned meaning to people and places and things, and not just what did I see, but what does this mean in the context of my life? And that requires a different architecture, not just retrieval, but reasoning, understanding those relationships.
The optical sensor that pulls in images and the microphones that pull in audio, they pipe that as fast as possible over Bluetooth down to your phone. And your phone acts as a relay point. Now, we're in the midst of, without sort of telegraphing some of our future plans, but you can probably surmise where we're going with this. we're in the midst of trying to keep a lot of the AI inference of that rich media, the images and the audio, locally about your person. And we'll have some exciting announcements about that soon. But in the meantime, the phone is the relay point, and then there's a small model that does inference over the images, and another model that does inference over the audio. And then we discard that rich media. We don't retain it. We don't save it on our servers or send it to anyone else. We discard it. And we transform that inference into these mathematical strings, these sort of string of numbers called embeddings. And embeddings are sort of like this really deep native way for an AI model to understand the nature of something. A text is something that is human created for our own benefit. It's not something, deeply native to a model's own requirement. And so these embeddings keep things like super light, super low latency, and private. Because if anyone ever got a hold of those embeddings, it wouldn't be the images and the audio of your life. It would be just a string of numbers, and no one would be able to make sense of that.
So the glasses capture the images and the audio. It Bluetooths it to the phone, and the small models do the inference. And then the images and the audio, well, that gets deleted immediately. It's not stored, it's not sent to servers, it's discarded. What remains are the embeddings, so not the original content. Those embeddings get indexed. Vector search for recall, graph ontology for reasoning. This is a really nice way to work privacy in at the architectural level. The systems, well, they can't read your images even if they wanted to. They don't exist. That is important for an AI-first product.
People paint everything that's happening now with one brush, and it's called AI. And AI, of course, as we know, is an umbrella term, and it's something that's been with us for a long time, actually. Many different AI techniques that people have been using for a long time. It didn't suddenly just get invented in 2022. What we found, and I think this is what a lot of teams find, is that there is no getting around the nuts and bolts of just good data science. Quality data into a system, quality, efficient systems built to process and store and transform that data, and then quality systems to enable the recall of that data. The data science, which has always been important, that's, if anything, just been elevated in importance because the cost and latency implications are now that much higher.
LLMs didn't eliminate data science work. They made it more critical. Poor quality data, the LLM hallucinates, or it has to reason for longer, and that spikes cost and latency. Unstructured data, the LLM has to work harder to make sense of it. More tokens, more time, more money. But quality data, efficiently structured, properly indexed, the LLM can work fast, lower cost, better results. Again, it always comes back to context engineering.
What I mean by that is this. You have a large language model that, of course, you can leverage to do cool stuff with the data. But if the data is of poor quality, then you're more likely to get hallucination. Or the language model has to reason for longer, which means that you're going to have spikes in cost and latency. Even if you get quality data in, if you're just sort of throwing it unstructured into some repository somewhere and then throwing a language model at that, then the language model similarly has to work a lot harder to understand and make meaning of that unstructured data. But if you're painstakingly designing a good system to structure and cleanse and prune and connect that data, it's like, you know what it's like? It's like hiring a sous chef and having the world-class sous chef to wash and prepare and cut and have all of the ingredients ready so that the master chef is just quickly able to integrate and reveal a beautiful dish.